There it goes. Okay. With my speaker somehow. Okay, guys, ready? All right, so you tell me. Questions. Questions about this one. Who could not do this one? Who struggled? This one was okay? Which one everybody likes? Regan. The inflection points. Yep, I can move it up. Okay. So we have 5 roots, 4 turns, 3 inflection points. That's how we know how many we have. Now what happens is your concavity says, I'm going to make a cave down over here, and I'm going to make a cave down over here. But then it says, well, wait a second, I'm going to make a cave up over here. I'm going to make a cave up over here. So if you notice, this one is shared by a down and an up, so we've got to find the inflection point. This one is shared, we've got to find an inflection point, and this one is shared. We have to find an inflection point. Kind of make the motions of your cave. You'll see where you have to find an inflection. An inflection point is halfway between your mins and your maxes. So the average of the x's. Look for the average of the x's. So find your A, x, guy, and find your B. Add them together, divide by 2. That'll give you your x value. Then go into your calculator and do second calc, number 1 value, put that in, and find its y. It's not always the average of the y's, because it doesn't fall depending on how your graph looks. This guy, same thing for this one. Take the b, take that x, take the c, take that x. They're just negatives of each other. They're inverses. Add them together, you get 0, and that's the 0, 0 point. And this one too. Take the c and take the d, add them together, divide by 2, and find the x. Sound good? Does this have symmetry? Through where? Through the origin. It has symmetry. So is this an odd or an even function? It's an odd. If I replace all those x's with negatives, oops, negative x. If I replace these, look what's going to happen. All the signs are going to reverse. So if I factored out a -1, I go back to my original one. That tells me this is an odd function. And you can actually see your symmetry. See your symmetry through those points? You can see your symmetry through the origin. That's what's happening here. So it's kind of nice. It's almost like a self-check. If this comes out, this has to come out. This comes out, this has to come out. It's kind of nice to see that part. Are you okay with the inflection point? Okay. It's easiest if you kind of just trace concave down, concave up. Whoops, just shared it. I got to find an inflection. So halfway through, I changed my mind and I concave up. Halfway through, I changed my mind, I concave down. Halfway through, I changed my mind, I concave back up again. Kind of say it yourself real simple, like it makes a little more sense. These are your x-intercepts. Don't forget, you still have to find me your y-intercept. And you can clearly see it on your graph, but I need to see it algebraically. Just show me the substitution for zeros. Just say 0 to the 5th minus 5 times 0 to the 3rd plus 4 to the 0. Just show it to me like a substitution. I need to see those algebraically. And everybody okay with the increasing, decreasing? That's the same old we've been doing. To the highest, to the lowest, to the highest, to the lowest. Okay? Your domain, this is nice, a domain and range of all real numbers. Because they're all real numbers, all of your parts should cover the whole domain when you're doing this. Questions? This was the easy one, huh? Okay. So let's move on. Okay, these were synthetic division. They didn't say they had factors, so they could have remainders. All right, let's start with this one. How does this one work? Did it say synthetic? It said divide, right? Yeah. So how did you divide?
No, I did that. I was looking at the wrong problem.
So it looks scary?
I gotta read it.
Okay. Okay, we'll work on 4. How about this one? This one looks, don't forget it looks like this. Divide by, that's what it looks like.
Why would it be a 62 and, like, why didn't you add 176 and 62?
Because when you write, when you get this, isn't your last term x to the 0? Right, so it really comes out as your constant term. Like even think of a trinomial. Don't you have x squared plus 5x plus 7? That's where your x to the 0 is. That's x to the 1. That's x to the 0. So you, just like you count down up here, you're going to count down over here as well. And then what's left is your remainder. We only have one root over here, so you're going to only get one remainder. When we have a double, you're going to get 2. Can everybody do this one? Okay, did you remember to put a placeholder? If you don't put the placeholder, it's completely different. Okay, and remember, front end division. x4, say it to yourself real simple. x4 over x1, x cubed, x3, 3, 2, 1, here's my x to the 0. And then what's left is your remainder. Don't forget to put your remainder over your denominator. Now, if you multiply this times this thing, and then at the end you add in 176, you come back to your original. Just like you do for long divides. Okay, this one had a trinomial. Divided by a trinomial. So the first thing we said is the leading coefficient always has to be 1. Is this leading coefficient 1? So we have 2 terms here to divide by, and the rule was take each one out the opposite way. -2, +1. Let's take these out. You're going to do you're going to do a synthetic division. Yes?
Yeah.
Set what equal to 0?
Like when you have a polynomial, I thought you said equal to 0 and then
Well, these guys, yes, you said equal to 0. But each one of them had a separate thing, a separate problem. Remember this one? We said we technically have to factor out a 2 first. We had to make this equal to 1. And so then you could set this piece equal to 0. But this is a trinomial, so you can't do that. A trinomial is the only one that gives us the double divide. Remember at the end, you divided everything by whatever you factored out. Remember me, I was telling you to make sure you mark this and remember to do it at the end? Well, I'll do one of those in a second, but let's hit this guy. Because in a trinomial, you're going to use only the last 2 terms, not the first. But this has to be a 1 before you start. If this isn't a 1, then you have to factor it out. And then you're going to use these last 2. But then at the end here, you're going to divide by what you factored out. But I don't think I would give you one of those.
why is it +2 and -1?
Because it has to come out the opposite way. Like this one comes out the opposite way, because technically think about it, that's a factor. So isn't whenever you factor something, when you set them to 0, don't they come out the opposite way, right? Kind of like a factor versus a root. So you're pulling out your roots. This is the only one that works so weird. Pulling out your roots, and we're dividing. Now, let's start. You've got a 1, you have no x squared, you have no x1, and you have a -11. Always multiply from the left to the right. Bring down this guy to start. From the left, -2 times 1. Go to the right, -2. But you got another piece. 1 times 1. Go to the right of this guy. 1. Stop and add this one down. And repeat your process. Just make sure you keep going left to right, left to right. -2 times -2 is what? You got another one. 1 times -2 to the right. Now, once you hit the end, you stop and you just finish adding down. This adds down to 5 and this adds down to negative 13. So you were x cubed over x2. What do I start with? x1. This is x1, x0. Now here's your remainder. Work your remainder backwards. This is x0, x1. Because how are you going to label that? You need to have an x with it, right? You need to have, they have to be in descending order just like these guys are. So this is x minus 2, and here's my remainder, 5x minus 13 over my denominator, x squared plus 2x minus 1. You have to have x values there. They have to be descending. It's easier to work, well, if you want to work it forward, it's going to start with an x anyway. It's not going to be anything but x. It's just, I find the remainder easier just to go backwards. And this one has a double divide in it. We did these. Remember? Now, when you get something like this one, oh, let's just wing this. Okay, when you get this situation says I've got two terms in the denominator, which is fine. I can make a factor, but my leading coefficient is not a 1. So just like when you completed the square, and completing the square, you had your leading coefficient to be 1. You had to factor it out, and then later you redistributed it. Kind of works a little bit different when you're dividing because you're factoring. So we're going to factor out the 2. And then when you set this equal to 0, the 2 goes away. X is equal to 1/2. But remember this too, because then when you divide, you're going to take this whole row and you're going to divide, except your remainder, and you're going to divide it by 2. Remember doing that? Just be careful of that one. Your leading coefficient, whatever it is, if it's a square of x to the 1, it has to be 1. A little better? Watch these double divides. These are trickier. Was that all I gave you? Or 2 more? 5 and 6. Okay. Yes. Try home. Because you're only really dealing with the last 2 terms. You're only always dealing with the last 2 terms. Find the real zeros. So in the number 5, how many zeros should you have? 3. What's the difference between real zeros and all zeros? Imaginaries. Good. I don't need the imaginaries. I want them to be real in my real number world. If it's an imaginary, it will say find all zeros. And then I need you to find the imaginary.
This says find real zeros. Yeah.
Oh, yours says find real zeros?
I got that confused. There's only 2.
I'm confused too. I don't know how that changed because this is my worksheet. So okay. So there were only 2 real ones. Yeah. But so we can absolutely just take a little bit and we can just go through finding the imaginary part. Sorry about that. Everybody okay with this?
Yeah.
Dividing these through? You need your calculator to help you. You have to get 3. So you have to get this down to an x squared. Once you get to an x squared, you can factor x squared. If you found 2 of them in there, divide it again. Once you reach this point, and I kind of like the dividing again. Okay, when you get to this point and it comes out over here, here's my 0. Yes, that showed me that it's a root. Divide again. Divide by the last one. Bring this down and divide again. And then again has to be 0. So what you're left with is this. If I took 2 away, I'm left with x to the 1. This is my factor. This is what's left. So therefore, what's my last one? X is equal to 5. You can just keep dividing all the way through. The way to do this is the algebraic, so it's showing me algebraically. Yeah, I can graph it, and I can even find 5, 0 in there, because they all worked out to be in my table. But I need that, like, algebraic way to find this. And you can't factor that otherwise. We have no x to take out or kind of stuff. Okay, this one, if you found your real zeros, you got down to here, and this part, you couldn't factor. If you got as far as realizing that this is going to be a negative, looking at your discriminant, then those were your imaginary parts.
What is the difference, like, how do you know when to do the double divide or the two side by side? Like the last problem.
There's nothing to divide by for this. There's no divide.
So whenever you have to divide by something, that's when the two are next to each other?
You're going to see divide by. It's going to say, just like the other one, divide by. This is just going to say pull out 1 0 at a time. Just give me 1 0. All you're doing is looking in your calculator. You're not even, in other words, this would have said divide by x plus 3. But we don't need to do that. We're just going to pull out all the zeros we can. If there's 4, we need to find at least 2. So you got to at least go through 2 steps of these. And then once you get to a square, a quadratic, you can factor that.
So like for the last one, did you use your own your calculator, find the zeros and divide by them?
That's what we did all the way. That you can do it this way.
So you don't have to do like factor out the x squared minus x.
Over here?
Yeah.
No, what if you get another 0? Just to keep dividing. The last one is your last factor.
Yeah, I mean, like, do you have to, because I just divided, like, how you did on the right, like, I just went into the calculator and found them and divided by them, so I didn't, like, make the,
Did you do this though? Did you do synthetic division? How did you divide by them?
the division you did on the right, like, that, I just went into the calculator and found, like, -3, -2, and, like, 5, instead of, like, finding them algebraically.
Did you divide this by 5? Is that what you, and you can keep dividing by 5, it'll still work, and then you get a 0 at the bottom. You found all your roots. And so Amanda went down one more. She divided this by 5. So just ignore this. So when you pull down the 1, 1 times 5 is 5. This becomes a 0. So this is my last factor. If I just see this as a 0, I know they're all factors. You can do that too. You can keep, because this one did show you all 3. Are we okay with number 6? If it says all zeros, you're going to find me the imaginaries?
You just left it as like radical negative, like -1 plus or minus radical negative. So is that a there?
Just like this.
You have to put the I.
You have to put the I. Yes, because what happens to negative radical 3? It doesn't exist, right? So how do we take this out? We take out the square root of -1, which is I. You have to take out the I. Okay?
So where do you get the radical negative?
This was the quadratic equation.
Oh.
I just didn't do the whole steps to it. This was the quadratic. I just did the quadratic equation. You could do complete the square. You can do whatever you like. Generally, if it's going to come out with a fraction, I'll use the quadratic equation. If I complete the square. I'll check it out. Thank you. Questions at all? No? Is it sounding familiar again? Yeah? It probably is that we just did this a little while ago. It feels like a little while ago.